So since we can be any number less than negative 8.5, we'll shade everything to the left of negative 8.5 where we have the bracket. And it'll go on forever, so we do need to shade in that arrow, indicating it could be any number going on towards the negatives forever, approaching negative infinity. Okay. So the second half of all these problems is going to be just like what we were doing on the front. It's just we have to get to a position where we have a single variable with a single variable inequality. So looking at our next example, we now have a situation involving fractions and parentheses, which fractions typically give a lot of students problems, but I'm going to do a little trick here where in the first step we can kind of get rid of the fractions and turn them into whole numbers so that we're not dealing with so many fraction operations. So the trick is, if you recall from previous classes, that we can clear all our fractions and turn them into whole numbers by multiplying every single term on the left and right hand side of an inequality or equation, as long as we multiply by the lowest common denominator of each of the fractions. So if we look at our few fractions in this problem, we have 2/3, we have 1/2, and we have 1/2. So our denominators are 3 and 2. Those are the only two denominators that we have in this problem. So the lowest common denominator, if we are trying to make, combine two fractions like this and trying to have a matching denominators, the lowest common multiple of 3 and 2 is 6. 6 is the smallest number that both 3 and 2 will go into. Okay? 2 can be multiplied into 6, 3 can be multiplied into 6. So that's going to be our first step. Let me write that in here. We're going to multiply by the LCD, the lowest common denominator, which in this case is 6. We're going to do this in order to clear our fractions. That'll be the first step. We'll get rid of those fractions right off the bat, which will be pretty nice. So I'm going to take our original problem, rewrite it here, and then in a different color write in where we're multiplying. So we have 2/3 times parentheses r minus 3. We could go ahead and distribute it in the 2/3, but I'm going to multiply things by our LCD first so that we're not dealing with the fractions. But let me rewrite what we have to begin with. R minus 3. I'm going to leave a little bit of space in between things so that I can multiply by the 6 that I just mentioned. So we have a little bit of space there to stick in a 6. Greater than, we have the 1/2, 5 parentheses, 5 minus r. I'm going to leave a little bit of room out front there. And then we can put a 6 on the end. So right there, that is our original problem. I haven't changed anything yet. But now I'm going to do the same thing on the left-hand side of this inequality that I'm doing on the right-hand side. I'm going to multiply by a 6. So on the left-hand side, I don't need to multiply all three of these by 6, because as long as I multiply the 2/3 by 6, it's then going to get distributed into that parenthesis anyways. So multiplying the 2/3 by 6 handles that whole parenthesis there. But then since there's subtraction in between them here in this 1/2, we need to multiply that 1/2 by 6. Okay, our LCD. On the right hand side of that inequality, I need to multiply that half by 1, or that 1/2 by 6, and then that's going to end up getting distributed into that parenthesis. So the parenthesis handled, and then that 2 on the end, I need to multiply that by 6. So that's that first step. We're multiplying by the lowest common denominator, and now when we multiply through, you're going to see why that is an effective method. So looking at what we have here, we need to multiply 6 times 2/3. Okay, what does that give us? Well, if you multiply 6 times 2, that'll give you 12. 12 divided by 3 gives you 4. So you see this turns into a whole number. Just gives us the whole number 4. So we have 4 and then parentheses r minus 3. Minus 6 times 1/2 will give you 3. 6 times 1 is 6, divided by 2 gives you 3. It's greater than 6 times 1/2, again, that'll give us 3. Parentheses 5 minus r. And then plus 2 times 6 is 12. So in one step, we've gotten rid of our fractions. Now this problem really becomes just like what we were doing up above here, where we have some parentheses, we have variables on both sides. We need to distribute the number outside of the parentheses into the parentheses, and then we can start moving things around, combining like terms, and getting our variable by itself. So we have a 4 that we need to distribute into that r minus 3 parenthesis. We have a 3 that we need to distribute into that 5 minus r parenthesis. So let's do that. Change color here. So this is technically 4 times that parenthesis. That becomes 4r. 4 times a negative 3 becomes minus 12. Bring down the minus 3 is greater than 3 times 5 gives you 15. 3 times a negative r will just give you a minus 3r. And plus 12, bring that down. Okay, so that works so far. We can combine any like terms on both sides. It might help to do that right off the bat. Make it a little bit easier. Negative 12 minus 3 will give you a negative 15. So we have a 4r minus 15. It's greater than the 15 we can combine with the 12 to give us 27 minus the 3r. So now we have nothing left to combine on both sides, but we want to move things over so that we can get our variable terms together on one side, our non-variable terms together on the other side. So I can add a 3r to both sides to cancel it out here, to cancel out the negative 3r. So this will give us plus 3r here, plus 3r here. At this point, again, if you want to draw this kind of imaginary dotted line to help you out. So 3r plus 4r gives us 7r. Bring down the minus 15. Bring down the greater than symbol and bring down the 27. Our 3r's canceled each other out there. Now we would need to add 15 to both sides to cancel out this minus 15 here. So add a 15 to cancel those out. Of course, we have to do the same on the right hand side. So these will cancel. On the right hand side, we're going to have 27 plus 15. So we're left with 7r on the left is greater than 27 plus 15, should give us 42. Last step, just divide by 7 on both sides, because that's how we get rid of our coefficient. So if 7r is greater than 42, we divide by 7 to cancel out the 7. And the final answer, r is greater than 6. Alright, so now we have our answer as a single inequality. We want to convert that into interval notation. So saying r can be any number greater than 6 means that it can go from 6 to infinity. So writing this in interval notation would be 6. 6 would get a parenthesis because it's strictly a greater than, not greater than or equal to. And if it can be any number greater than 6, it will go on forever, approaching infinity, which also gets a parenthesis. So there's our interval notation. And then lastly would be graphing it. So we have from negative infinity to positive infinity. Here's 4, 5, 6, we'll say 7. So we have a parenthesis at 6, and then everything to the right going on forever, including the arrow. And that is what our graph would look like.